Well, hello there. My name is Cord Campbell, and today I'm going to walk you through a couple of projects that I've built recently that I've put up on GitHub. And if you're interested in that, there are links in the description, or in the comments, I should say. And I'll put them in the description, I suppose. So what we're looking at is a simulation of. I just did a stream and then I had to delete it because it just got silly on it. So whatever. So you'll note here, like, this is got a purple thing. It says take helm. So right now this is under the control of OpenCPN. And so OpenCPN is a chart plotter, open source chart plotter that sailors use. And so we're wiring it up today into this simulator. And I've had this work done by coding agents, one of which you see working here on the right. And it's currently working on like doing documentation and some changes on the website that I wanted done. And it's in charge of that. That's that agent's job. But when I was doing the stream that I just deleted, what I realized was that it sort of knocked me off course was that this agent controlling button, I can't turn it off and I can't click on this. So I have all sorts of controls still as some, the operator of the boat, so to speak. I have control of like the sheet, and the sail itself is modeled in the browser in JavaScript, in React, in a physics engine, and designed to render the forces on the sail. So that's what you're seeing here. This is the max force of all of the forces on the sail. So it's not indicating that the sail is, like, that's not direct. Well, I mean, you can look down at the numbers to see what the total drive of the sail is. So this sail is being modeled with this wind angle and our heading and current, which you can see is underneath the purple surface. The purple surface stuff is for just visual movement. Otherwise, it doesn't look like it's moving if there's not that. And then this is the current indicator. So these are just visualizations of these numbers. These numbers come out of Signal K, which is an application that server application slash, like hub for your boat's data. So for the like NEMA 2000 network stuff and all that stuff, Ethernet networking stuff like that on the boat. Boats have always had networking stuff on them for sensors and stuff for a long time, even basic ones. So the control right now is, I don't think I have rudder authority, which is not great, but I probably have engine authority, and I do. So let's see which engine I turned on. This one, the starboard engine, is on. And so I have that control, so I could kill it and I could drop the sail. So, but I don't have rudder authority because, and it's this, I don't think I have rudder authority. Do I have rudder authority? I should. I don't, because it's under autopilot, I think. Yeah, it's not moving. So we're going to fix that. So this is how we're going to do it. So we're going to go into our terminal, and I've got, somebody wants to create a sticky note, so I'm going to allow that. And so I don't think you'll be able to see the stickies when they pop up, although if it does pop up, I can show you it by adding it to the OBS Studio interface. So we're in a terminal shell here. There's another one over here. We don't need to really worry about what's going on in it. It's not important. So we've got two agents. This is the Meridian agent, which is a navigation app. And this is the agent for the simulator that you see. It's weird because when I click off of it, see, it doesn't look like it's being animated. So I'm sorry about that. Let me see if I can. I guess it's only animated if it's visible to me, which is kind of weird, but it's a capture thing probably. So, okay, so I'll just keep it visible on my other screen. So, the this agent that's in charge of the sim is going to, I'm sorry, I've moved it into a window that, there we go. So you can see all the controls. Let me make this a little bit smaller. Make this window bigger. Okay. So, and you don't have view of the bottom. Let's see if I can. Okay. So the view of the map is going to be here, is going to be OpenCPN, and we're going to set a route to Prickly Point. So we're going to say navigate to here, and we should see the boat turning, and it is. I want to open this up. So this is, I just want to show you this real quick. This is the force. I don't know if I was saying it and it wasn't visible, but this is the forces on the boat. So let me scoot this up a little bit and see if I can. There we go. That's probably fine to cover that up like that. So that's OpenCPN. Yeah, I mean, I just noticed that, I guess. I don't know why I can't select OpenCPN again. Hold on a second. So I'll just remove that. I have a sticky note to throw up as well, but let's do the fix our sail. We keep using that one. Okay, so we have 850 newtons of thrust now on the sail calculated, and then that's fed back into the model of the boat running on a back end, on the back end. And in this case, this is running on a Raspberry Pi that's in my, underneath my, hooked up to my TV. So we want to fix this thing where we can't take the helm. So now it's on a heading and it's under control of OpenCPN. I'm unable to uncheck that. So I'm going to ask that to be fixed. So this is how I'm going to do it. I'm just going to talk to it. So I'm in the simulator right now, and we've got, so I set a route in OpenCPN, which uses Signal K, which we're connected to set a route. I just said navigate to here, picked a point to navigate to here. Let me get that back up too while I'm talking to it. And so let me go ahead and throw that back up real quick before I finish that. Let's see here. I've got to make it a And I know you can't see this, but I've got to make it. Oh, I want to capture the open CPN. It's weird. OpenCPN has disappeared from the list, so I'm going to close it. This is so funny. Okay, so I'm going to reopen OpenCPN. I don't know what happened to it. I mean, I mean, I can see it, but it's working fine. It was totally working, but it's not visible in OBS Studio. So now let's see if I can see it. I hope it's not OBS Studio. So I'm going to cancel the ad and I'm going to delete that. Yes. So we're still on a good heading. I'm just trying to get the map back up. Let me finish doing that. I'm going to try one more time. See if I can add. So window, oh, I have to change the Windows version. So the capture method has to be Windows 10 and up. And there we go. Okay. All right. Sorry for the diversion, Claude and audience. All right. So what we're going to go back in here and we're just going to tell it. So I have it under an open CPN route, as I mentioned, and it, when I refreshed, and I thought we just did a deployment to fix this, but when I refreshed, this is on the Pi. When I refreshed, I can't uncheck agent controlling. And I think it was an issue with like something about the plugin for OpenCPN. I don't remember. And then the take helm release to manual at the top needs to be, well, it needs to work. I suppose that's supposed to be a substitute for unchecking the box. So you should just, whenever I click that button, you just trigger the box uncheck, and you always force it to be unchecked, no matter whether that button is, there or not. It's always there. It should also, the button should also change to say helm control is yours or something like that. What am I missing here? So now we're going to watch Claude Code Fable 5 crank on this. And it's going to go and like look at all the like the front end code basically. So, I mean, the only thing it's affecting is the rudder, but I mean, we would want dual inputs as well. So I think I'll mention that to it. So like if I have autopilot selected, which normally autopilots just follow to a heading, that's the basic autopilot function, is that I should be able to alter the heading, but then if OpenCPN has a heading, then shouldn't we alter the heading there? So then I just added in some additional context to the AI. And there's an ongoing debate right now about whether or not someone can sit around and talk to. It's what people call vibe coding, but I mean, I don't even know what that means. There's also the idea of like just asking once for something and then getting it, but I mean that you're going to get really poor results from that. And people judge AI based on that, but I mean that's just a thing to post on social media. So in reality, what you do is you sit and you test and you test and you test and you test. and then you tell it how to test itself. And so all these things have tests that are written that are software tests, but then I'm also testing it. As you can see, you're testing it now too. You can go online and use this right now without the autopilot or OpenCPN stuff at skiff.deepbluedynamics.com. That's my pitch. So that's the sponsorship. So go visit deepbluedynamics.com. And so that's me. And so, um, like the this particular project, I've been working on it for probably about a month. I've had something bobbing in the ocean, right? And but then I didn't have like the physics engine all planned out and all that stuff. So I had a very large uh, research run that I had another agent do that collected a bunch of data. Sometimes I do that on Claude, so I'll just go to Claude.ai and I'll talk to Claude and let it do the research. Sometimes I run my own research agents, and I'll use various agents to do that. Every agent that I've talked to, pretty much, excuse me, has some form of going out and gathering data from the web. But we also go out and search myself for data that um, we need for informing how to build what we're building. So in the case of, sorry, I'm getting something to drink. In the case of that, we need to go out and, clone a repo or something like that and analyze it. We've done stuff like that too. That we've only used um, permissive like we use, for example, in the piece of software that you're looking at with the tabs at the top, this is a fork of hyper term, or hyper. It's now called hyper, but it used to be called hyperterm, and it's an Electron multi-platform terminal emulator. And so I forked it, which is totally valid, and I renamed it, which is also valid. It's a fair thing to do. It's totally allowed. And left it open source and added Rust controls to it, and then reworked the UI pretty much completely. So a lot of it is based on code that was written by humans over many, many years as a terminal emulator, and I built on top of that. So it's not as if I said, hey, create me a terminal in Electron. I didn't ask it to do that. So a lot of planning went into all of this. So for example, make sure that we're not going somewhere weird. I don't know where we're going. We appear to be going with the wind. So the model for the asymmetric, I believe this is what's called a code zero, but it's an asymmetrical sail that can be flown a couple of different ways. I think like a symmetrical sail would be, I think, be connected to both the port and starboard side, forward somewhere, I suppose, on the nacelle, and not like sheeted back on the helm winches, whatever those are. And so the forces for the sail are computed inside the front end, and the forces for the boat itself are computed on the Raspberry Pi in an engine. So those both of those engines were informed by these research runs to find the best way, what is state of the art. And that includes like going and looking at research papers and that are published online as well, research in the area, and all of it is used in the licenses that are provided. So the model itself is a Lagoon 450S, which I purchased, and I think it was about 120 bucks, 130 bucks, something like that. And you are able to put it into a commercial product. So the license allows putting it into a commercial product. So I rigged it into this HTML viewer. So there is only one thing that comes out of what you're looking at that really matters, other than the controls for that we've talked about for that feedback into something like OpenCPN, is that it's simulating a boat so that you can get signal data off of the simulated boat. But you want to make sure you do care about the fact that the sail plan that we're displaying is producing accurate forces, and we're attempting to run a very accurate model on that in the browser, which is why we have the color indicators of the forces. That's just max force in the middle for whatever force we're at right now. We can speed up the wind. We do have control of that. And so we can increase the wind speed, and we can change the wind angle as well. And so I think we were wanting, so it looks like maybe they fixed it. So we're going to enable the autopilot, and then we want to set a heading of, this is just like manual control of the boat through the controls that are here. So this would be like an autopilot on the dash or something that we're simulating now. But we're still tracking inside of OpenCPN, we're still sending in data. So we're still sending telemetry into OpenCPN for this. Now, I think, let's see what it's saying. I'm just going to scroll back and see what's touching. So it's editing the, yeah, it edited, I did a little editing. Oh, so it's just updating how the tool run calls and how it takes control. So it took control like that. This is technically an agent according to the sim. This is a controlling agent. So OpenCPN would be a controlling agent. It would be no different than an AI taking control. You're just controlling it with OpenCPN, which is then controlled by the operator. So I think that's fixed. I think that's about what I wanted to cover in this. I'm streaming because it's just easier for me to do it. I don't want to like spend a lot of time producing a video, but I will throw my face up in the next one. I'm working on, so what's next for this is I'm working on the track for the boom. And so I'll do that in the next video. Is I'll do a session working on the boom and the traveler for the boom vang. And so that will be, something like figure out how to get this boom swinging back and forth so that when we put the sail back in, that it's attached to it and it moves the sail. So then we can render that as well. So we already have the code ready for rendering this. In fact, if I think I can't drop it because it's disabled, but this is like offline. But when we put that back in, then we'll have the main sail. Then we'll work on the front jib furler so that we can unfurl the jib and actually roll it up too. Hopefully, I mean, I say roll it up when like the animations in this are good for visual feedback. So it's like if you move the rudder, let's move the rudder a little bit. You can see the wheel turning. It's a little jerky. It needs to not like wang it over. So we'll just tune that or put a slider in there for sensitivity. In fact, I'll do that now because it just makes sense. The rudder control is super sensitive. I noticed like the AI or the whatever the autopilot function just slams it over. It should definitely ease in and ease out of it. I mean, if I do yank over the direction, and I kind of feel like the direction in the middle should be the current heading, which I guess it is. So if I yank it to the port, then it goes port. But I feel like I should have like check boxes or ticks or something that it jumps to, so that it doesn't go bonkers. It just seems to like really slide out of my hand, and then all of a sudden the rudder's like full over. So we just describe what we want as a behavior inside the objects on the screen. And then we have code written to like satisfy those constraints. But like we don't, the process is not, I mean, I know it's going to go edit the HTML page for it. But then like you can kind of look at this and go, well, if it's close enough in the sim, because this is you're driving a simulator, you're trying to collect numbers from the actual back end physics, which is a little bit more tightly controlled. So a lot of what you're seeing here is not mission critical, is what I'm saying. It's not mission critical that, for example, the sail, does not currently interact with any other object. It's not supposed to. It interacts with itself and the top and the tie points, but it does not. It doesn't. You can see it's flopping through all the lines and stuff, and it doesn't matter because I'm not building this for ultra accuracy of that. I'm building it for accuracy of being able to get the forces out of it, and you can see that we've still got 2,000 newtons of force on the sail. So let's tweak that around. We want to assume, is that accurate, right? We want to know, is that an accurate representation of it? Well, we turn the wind up. So the wind is at 16. So the wind's at 30 knots, right? And we've got this sail out. This sail would probably, I mean, it's pretty red, but we don't have like, I don't have, written down or defined in here. We're now generating 3,700 newtons of force, right? So let's go look, and I'm just going to do that myself. Is I'm going to go look and say, what force will blow out a code 0? So it says a true wind speed of 15 to 20 knots will typically blow out a code 0. So this sail just got blown, right? Because I cranked the wind up to 30 knots. It said 30 knots, right? So that's how much force, if the sail didn't blow, right? That's how much force the sail would be exerting in thrust. So let's see if we can like get this down. So what I want to know now, so I'm going to take that information and I'm going to ask Gemini on Google. I'm going to say, so I have a result, which you could go get yourself and look at it. I'm going to say, how many newtons of force to blow it out, though? So assuming that we wanted to fly a spinnaker, because we are flying one at 30 knots, so, and it's not blown out, is that so it says 5,000 newtons of continuous sheet load pull. So we were at 4,000. So if we had, so I think what I'm going to do is copy all this, and I'm going to paste this to Google. Get Gemini, and I will say, it's saying it's not blowing out yet, but is approaching extreme structural instability. So I wonder if we could like tweak it a bit and see if so this thing right here will pin the luffs. So the idea is that it's not that I mean it's going to be. I'm going to change the wind direction just slightly. I'll just change I'll change our heading. Let's see, where are we? We're way out in open water. So I'm going to change our heading to that. We should have an updated version of this here in a second. And then let's try letting the sheet out. So that's still, we've got 4,500. Wow. So we tipped over. Or the simulator is, oh, it's resetting it. We just sank our boat. Okay. So I wonder if we have our, probably back in Prickly Bay. We restart in Prickly Bay. So it's retaken that route. So let's set a course. You can't see it when I'm setting around. It's so weird. It's just a YouTube thing, I guess, or OBS Studio thing. I think OpenCPN.
Base, this is Poised Goose transmitting. Two fixes are live. Take Helm now actually releases you to manual and stays released even with an open CAEP en route running, and the button is always there. Hard refresh to get that new button. And the red now eases in and out of a couple seconds instead of slamming hard ove. Give it a feel. This is Poised Goose. Ove and out.
Okay, so that was the agent informing us of the work was completed. And the reason it's talking funny is because it clips words because the model's only 83 megabytes in size. So that's a voice model that's running locally that's 83 megabytes in size, runs on the CPU. That's built into Hyperia, the terminal emulator we're looking at. So that looks good. So we're headed back out into the ocean again for the 100th time. So we're just going to keep running this simulation over and over again and continuing to refine it. And let's see how let me refresh this page. So it's under My Helm Control, and I'm going to enable autopilot. And we're getting an indication that OpenCPN is controlling. So now we're going to test this. So now we have helm control. And we want to be, let's enable the autopilot, and that's now under OpenCPN control. So we're headed out into the ocean. All right, I think that's good enough for now. So if you have any questions, drop them in the comments. I'm just getting started.